Hi, I'm Pushkar and I'm a master teacher in Vedantu in chemistry and I'm discussing JEE Advanced 2019 solutions chemistry paper. Right now, we're going to solve question number 15 in paper 2. This question is of matrix match type and there are two questions related with this matrix match, question number 15 and question number 16. This question requires thorough reading and matchmaking. It is not very difficult, but we need to observe the problem very curiously and very, keenly to get the solution correct. Let us see what is the problem. Consider the Bohr's model of one electron atom where the electron moves around the nucleus. In the following list 1 contains some quantities for n orbit of the atom and list 2 contains options showing how they depend on n. The first quantity is radius of the nth orbit. Second is angular momentum of the electron in the nth orbit. Third is kinetic energy of the electron in the nth orbit. And fourth is potential energy of the electron in the nth orbit. And the list 2 have been given proportional to 1 upon n square, proportional to 1 upon n, proportional to n raised to the power 0, and n square n 1 upon under root of n, option U. And now you have to see which of the following correct combinations considering list 1 and list 2 is correct. So before you start, let us discuss out that radius of the nth orbit, angular momentum, and kinetic energies, etc., how they are dependent on n, principal quantum number. We know that in hydrogen-like species, radius in nth orbit is given by n square upon z, and that is multiplied by a constant which is 0.529 Armstrong. This result you mostly remember. Also, you remember that angular momentum mvr is equals to nh upon 2 pi. The fact remains that the angular momentum am is proportional to n raised to the power 1 and r is proportional to Rn is proportional to n raised to the power 2. These are pretty straightforward facts, very easy facts. Anyone who is doing the Bohr's model will do this. Thirdly, the kinetic energy. Now, kinetic energy in the Bohr's model, if you remember, if you have gone through it thoroughly, then kinetic energy is equal to the magnitude of energy, En, okay, but magnitude of energy. And we know that the expression of En contains what? Z square upon n square multiplied by 13.6 electron volt. So this is kinetic energy, and indeed kinetic energy is inversely proportional to n square. And similarly, potential energy, if you remember, the potential energy is equals to simply 2 times of energy, and so it is also equal to z square upon n square with negative sign into 13.6 into 2. So if these facts are clear, then problem is pretty simple, straightforward. Both problems are pretty straightforward, related problems. Okay, Rn is proportional to n square, angular momentum is proportional to n raised to the power 1, kinetic energy is proportional to 1 upon n square, and potential energy is also proportional to 1 upon n square. So now let's match the column. Column A, option A, 3 matches with S. Kinetic energy is matches with H. It is not possible. 4 matches with Q. Potential energy matches with Q. It is impossible. 3 matches with P. Kinetic energy is proportional to 1 upon n square. Of course, it will match. So C is the correct option. And since it is a single correct option, you don't have to look for even the D option. So this C is the correct option in question number 15. Similarly, if we see the question number 16, which is also present here, same table. Now we have to see. Second is matching with R. Second is angular momentum, and which is R is n raised to the power 0, not possible. B is second option. B is matching with, second is matching with Q, It's also not possible because MVR is directly proportional to n. See, first is matching with P, radius of the nth orbit is matching with P. That is also not possible because radius is proportional to n square. And D, 1 is matching with T. 1 is matching with T is the perfect match. So D is the correct option. So basically the question is very simple, but you need to look very carefully into all the options. It's a time consuming problem, but very easy problem. So the funda of this problem is you must know the various dependencies in the Bohr's model. And even if you don't know the full expression, even if you don't know the full expression of Rn, which is equal to n square upon z into k stands for the 1 upon 4 pi epsilon e naught, and this is n square, so of course associated with h square zk upon 4 pi square m e square. That is the full expression of Rn. So you don't need to remember this. And similarly, the kinetic energy which we have solved is equals to z square into k square into 2 pi square m e raised to the power 4 upon n square h square, and where k is equals to 1 upon 4 pi epsilon e naught. Even if you don't know the full expression, if you simply know that they are related to how they are related to the constant n square and z, you can solve the problem. So that is a conceptual problem, a very simple problem. Stay tuned for the solutions to the other question. Thanks for watching.